Now let's work this problem. A, B, and C are the measures of the angles of triangle ABC. We want to prove that the sine of B over 2 times the cosine of C over 2 plus the sine of C over 2 times the cosine of B over 2 is the cosine of A over 2. Okay, so this is a quick application of what we know. Okay, so we need to see this expression. Okay, here we can remember what we know about the sine of x plus y. Okay, so we know that the sine of x plus y is sine of x cosine of y plus the cosine of x sine of y. Okay, here if we look at this one here, if we let x be b over 2 and y be c over 2, we see that we have this expression here. Okay, so we can rewrite this one as sine of b over 2 plus c over 2. Okay, and we remember one thing now is that A, B, and C are the measures of the angles of the triangle ABC. Okay, what does that mean? It means that we have, okay, A, B, and C are the measures of the angles. That means A plus B plus C is 180 degrees. Okay, now we can write this one as sine of B plus C over 2. And we can get b plus c over 2 from here. So we have b plus c over 2 is, okay, let me do it here. Okay, so here we have b plus c is 180 minus a. If we divide by 2, we're going to get 180 minus a over 2. We can even simplify this one as 90 minus a over 2. Okay, here we plug it here. Okay, let's plug this value here of b plus c over 2 here. So we have sine of b over 2 plus c over 2 is the sine of b plus c over 2, which is the sine of 90 degrees minus a over 2. Okay, now how can we conclude from here to get back to here? We can use we know this rule here. Okay, when two angles are equal to 90 and when two angles are equal to 80, but here we just want to remember when we have the minus here, when we have the sine of x minus y is sine of x cosine y minus cosine x sine y. So if we can't get that this is just the cosine of a over 2, we can rewrite this formula here. Okay, so we're going to have the sine of 90 times the cosine of a over 2 minus the cosine of 90 sine of a over 2. The sine of 90 is 1, cosine of a over 2, that's a over 2, and the cosine of 90 is 0. Therefore, we have cosine of a over 2. And that's what we need to prove. Okay, so we have to do all the steps to get to this result. Okay, so when we see these expressions here and when we have the triangles or the angles, we can just use this fact here that the sum is 180 and use these rules here. And sometimes we use the product. Okay, there is another way of solving this problem. Okay, if you don't see that this is just this expression here, we can use the product into, when we transform the product into the sum. Okay, and I think we have seen that formula before. Thank you.